Welcome everyone. Thank you for joining us for today's webinar. Just a little housekeeping before we get started. This webinar is being recorded. All attendees will be in listen-only mode. We'll open the floor for a discussion during the Q&A portion of the presentation. You can also type your questions into the chat box. I'd first like to introduce our Process Mechanical Department Manager, Barry Thrasher, who will talk a little bit about our company, and he will also introduce Jaime. With that, I'll hand it over to you, Barry.
Thank you, Laura, for the introduction, and thanks everyone for being here today. We have a really exciting topic that we'd like to share with you today, equipment dimensional verification, or as we have acronymed it, EDV. So, next slide. So, before we get started, I want to talk about engineering, CDI Engineering Solutions a little bit. So CDI Engineering Solutions is a full service chemical and energy engineering service company. We have a full gamut of services we offer, from project management to laser scanning to quality control and procurement. We have a network of engineering centers throughout the United States that we're going to look at a little more on the next slide. And we have an incredible team of multidiscipline subject matter experts that we really have a broad base of knowledge and a broad base of exposure to engineering solutions. So, next slide. So office locations, here we have a slide, demonstrating the office locations that CDI currently occupies, and offices and corporate office in Philadelphia, Pennsylvania. We have an office in West Virginia, located there in Charleston. We also have an office in Kentucky and located in Louisville. Midland, Michigan office, a Baton Rouge office, and we have 3 office locations in Southeast Texas. Also, to augment our engineering capabilities and capacities, we occupy 3 different high-value engineering centers located in India. The list is shown to the right, bottom right of the slide. Next slide, please. Like I mentioned briefly earlier, we provide a full gamut of engineering services and capabilities, from process engineering, all the major disciplines: mechanical, civil, structural, instrumentation control, electrical, and also we provide several specialty type engineering services, such as marine engineering and marine permitting, which can be some challenging aspects as well. We have a fully capable technical resourcing group for supplying very qualified expertise in seconded roles at client sites. We also have a procurement and supply chain management group where we offer purchasing, equipment expediting, inspection services, various aspects of that. And we have a large trained project management and estimating and scheduling group. Also, something that's somewhat unique to CDI, we actually do our own laser scanning. We own our own laser scanning equipment, and that's something that we supply to many of our customers. And something else that's sort of a specialty item is drone services. CDI provides drone services for various aspects. Next slide, please. So as we start many of our meetings, we begin with a safety topic, and so I would like to do a safety topic here that's pretty near and dear to me. I'm pretty active boater, so I want to offer a little statistic at the top. In 2017, of course, this is from the U.S. Coast Guard, They had reported roughly 4,300 boating incidents that resulted in a fatality. 658 fatalities per this stat. And also 2,600 plus injuries associated with this, and quite an astronomical cost as well, a monetary cost of $46 million in property damage. So with that, I wanted to go through a few tips on some safety aspects to make everyone a little better prepared for their boating outing. So number one, and life jackets are essential. Life jackets in today's market are very comfortable and lightweight, very manageable by the people on the boat, and it is definitely a safety device that you would want to utilize. There's, in today's market, with all the YouTube videos and all the instructional videos available to each of us, it's always a good idea to watch a boating safety video. Doesn't take long, and odds are you'll pick up something of great value there. Number three is to be familiar with the boating laws in your area. State to state, the boating laws can change, and it's always the best thing to do is to know the laws that pertain to the state in which you're in. Number four is to check your equipment and make sure it's all in good working order. Maintain your equipment, keep it in good working order, so when you need to utilize it, it is functional. Number five is a pre-departure checklist. This is a good idea so you don't end up with trips that are cut short because you failed to bring something with you that was crucial and you needed it. Number six is very important to us. Don't drink and drive a boat. Drinking and driving a boat, it can impair your ability to operate the boat, put other boaters and other people in danger. So we need to stay away from that. Dress properly. Some lightweight, light colored clothing, if you're going on a boat, is a great idea. It can keep the weather, the sun, and also other things that can harm you off of you. And number eight, don't forget your sunscreen. The sun can be very misleading. Even on overcast days, you can very easily get sunburn. Next slide, please. Okay, with that being said, I want to make an introduction to Mr. Jaime Arredondo. He is our mechanical department manager located in our Houston, Texas office. Jaime comes with us with quite a bit of experience, over 10 years of technical leadership in his field of mechanical engineering, both petrochemical, chemical, refining. Jaime's experience has actually been toward mechanical equipment design, scheduling, actually on greenfield, brownfield, turnarounds, some very high-end schedule-driven complex projects. And Jaime has been really active in fabrication and inspection requirements throughout his career and the many projects that he has successfully completed. So with that being said, I want to turn this over to Jaime and let him take you through EDV today. Jaime?
Thank you, Barry. I appreciate the introduction, and I'd like to thank everybody for attending today's webinar. In this presentation, I'll be covering the following agenda. Before I discuss our equipment dimensional verification service, I'll talk through some common risks in the brownfield construction projects. The focus of this meeting will be on misalignment issues between your equipment, piping, your equipment foundations, and between other piping systems. From there, I'll define what our equipment dimensional verification service is and how CDI uses the latest laser scanning technology to improve your typical inspections. From there, I'll discuss how our EDV helps avoid costly construction rework. And we'll walk through some of the benefits of using EDV for your time-sensitive and critical installations. From there, we'll turn it over to any questions that we may have from our audience. So first, let's talk through some of the common risks with the brownfield construction projects. Like I mentioned, the focus of this presentation is on misalignment issues. What are some of the misalignment issues that we have seen? We've seen some between your piece of equipment to your piping. We've also seen misalignment between your equipment and your foundations. And we've also seen it between two piping systems. So with those issues, what we've seen is longer construction time, higher construction labor costs, and schedule delays. So in the next slide, I'll talk about some common issues on piping in a little bit more detail. And then I'll talk about some examples of pieces of equipment that we've seen in some of our past projects. From there, I'll discuss the EDV service and how it helps mitigate these problems. Okay, so let's talk through some of the misalignment issues that we've seen in piping systems. The first example are of rotated flange. So if you can envision yourself trying to connect two pipe spools together, and you come to find out that the flange bolt holes are slightly rotated enough to impede you from putting your stud bolts through. So to fix that error, you would need to cut that flange, prep the weld area, realign the flange, and make the weld again. So due to that error, you had more labor time, you've had the cost of the weld, and you've had the schedule delay. Another example that we've seen is your flange angle is out of spec. So if you can see the picture on the bottom right, the flange faces are not evenly spaced. For this particular case, you may still be able to make your joint out in the field, but you're adding some stresses into your piping system that could be shown down the line. So as an example, during startup, as your system is heating up and building pressure, and as your piping is starting to thermally expand, this could expose this area to a leakage problem. From there, you'd have dire consequences to stop your startup process, decommission, go and fix the problem, and then start that over again, which would mean huge cost and schedule delays for your project. Another example, talking about connection gaps. So alluding to that of the two piping spools that you're trying to connect, you come to find out that one of them's too short. So you have a big gap between your flange faces. From there, you'd have to also make some cuts, replace the spool, or add material and make some welds to make that final connection. So another example is your design errors and clashes, scanning mistakes. A lot of the engineering firms these days will take scanning equipment, we go and scan your site, and then build the new scope into either 3D model overlaid on top of each other. If the scan does not get registered properly and the coordinate system is off a few inches from the real world, and you go in and fabricate all your design based on that, you'll have some misalignment issues during the construction phase. You'll have discrepancies of a few inches on all your pipe spools. So all of these examples add up to higher rework costs and schedule delays for your job. Next, let's talk about some of the misalignment issues with pieces of equipment. We've all been in a project where we have a replacing kind scenario. You have an existing old piece of equipment that needs to be demoed out and be replaced with a new piece of equipment in its place. with the intent of reusing the foundation and reusing the existing piping. You know, in theory, it sounds like a simple exercise, but in practice, it's often more difficult than it seems. And why is that? You know, first, the documentation of that old piece of equipment may not be available. And if it is available, the information within that document may not be reliable. Also, the as-built information may have not been recorded in the system. Also, modifications to that piece of equipment may not have been documented. So, if you can see the picture on your screen, this is a project where we were replacing a heat exchanger in kind. The dimensions shown in black are based off of the existing equipment drawing, and the dimensions in red are the actual as-built dimensions. So you can see the discrepancies of a few inches between the two. If we would have built this piece of equipment based on the drawing, we would have had rework issues in the construction phase. Other cases that we've seen is when you replace an existing piece of equipment that is carbon steel and you upgrade the metallurgy to a 316 stainless, there could be thickness changes of that piece of equipment which can throw off your nozzle projections that you're trying to mate up to the existing piping. Other example could be your anchor bolts. You know, you take the old piece of equipment out again, and you intend to use the old anchor bolts to set the new piece of equipment on. These anchor bolts, based on the drawings, may not match. That could have had some field labor to accommodate the piece of equipment that wasn't documented. So if you build the new one based on the old drawings, you may have some mismatch. What you don't want is you want to place this piece of equipment, you have a high dollar cost crane out of your field, you find out that the bolt holes don't align with the anchor bolts, causing your crew to have to core drill and fix that on the fly. So with that, these examples are some of the items that we've seen. It's had some lessons learned. It caused some high construction rework and schedule delays for your projects. With those examples, I'll introduce our equipment dimensional verification service. This is CDI's inspection service of 3D laser scanning equipment, piping, and structures, reviewing the output data against the baseline design and construction and fabrication tolerances. Through our projects and reading through research, we found out that construction rework and vendor errors account for almost 1% of your total construction cost. So for those multi-million-dollar projects, these errors amount to hundreds of thousands of dollars of rework, even millions. So with that, CDI saw the need to provide a service to help mitigate those problems. So how do we do it? CDI will use the latest laser scanning technology to go and scan your piece of equipment, your piping or your structure on site at the shop or wherever. We'll take that data, get it registered in our software, and then get that modeled, reviewed, and checked against the baseline design, which could be your equipment drawings, your fabrication tolerances, your construction tolerances, or your tie-in dimensional requirements. So for a small project, we like to say that our timeline is 1 week to perform this service from the beginning of deploying our team to the site, taking that scan, registering the data, reviewing that in our software, then getting that reviewed against the baseline design and outputting that into a report that gets sent out to our clients and their fabricators. So what will you receive if you select our EDV service? Once we do the data gathering, we'll take that data and start the thorough and extensive review process. We'll evaluate the critical areas of that piece of equipment or your piping. We'll develop a line item by line item checklist where each component will be reviewed against the baseline. Examples are the flange projections. We'll check those dimensions. We'll check the overall length, the width of that piece of equipment. We'll check the flange face rotations. Are those on par? We'll also check your anchor bolt holes. Do those match the anchor bolts on site? Will we have any clashes or not? And we'll list those out on our report. And our report is very visual. Well, you have the baseline design, and you'll have the measured dimension, and then we'll dictate if it's a pass or fail. If you can see on screen, the passes are shown in green, and the fails are shown in red. In the summary of this report, we'll list out all the non-conformances, and from here we can develop a mitigation strategy to fix the errors. Our service is a risk mitigation strategy for your critical fit items in your critical path. So by using this report, you can hold your fabricators accountable to build a quality product that's going to avoid rework in your construction phase. In this slide, I'd like to showcase the life cycle of a piece of equipment from your concepts of design drawings, moving on to the 3D modeling of that piece of equipment. That model gets overlaid on top of your scan and gets the additional scope added to that for your piping and your structures. From the modeling stage, it gets taken to the fabrication stage on the right side. So our EDV service would come in at the end of your fabrication stage, where the scan will be taken and reviewed against the previous design baselines. So by using our service, we have some great benefits. Some of them being having less engineering time, answering construction RFIs. So any misalignment errors that you can avoid on the stream means that you'll have to spend less money having your engineering firm answering some of those errors. You'll also spend less money finding the root cause. Another benefit is preventing unnecessary field labor costs and overages. So any misalignment error that gets avoided is time savings in your labor and any schedule delays. Another great benefit is accountability for your fabricators, right? You're having a technical assurance of that piece of equipment by doing a thorough inspection process, and you're finding any errors. So the vendor is going to know that you're going to be watching. Also, you'll set the expectations for any other work that they may be doing for that project or any future work on a different project. They'll know that you'll be performing this thorough review, and they'll be more cautious and have a greater inspection. For us, when we develop inspection requirements, we typically grade them from a 1, 2, or 3, depending on the complexity or criticality of that piece of equipment. The most complex, most critical piece of equipment gets thoroughly inspected. We dictate that up front. But the piece of equipment that are off the shelf, more standard pieces of design, those get less stringent inspection requirements and sometimes may default to a manufacturer standard. So there is some potential gaps of inspections that may not happen properly. Another great benefit is you can reduce production losses due to additional downtime. So kind of alluding to one of the examples that I talked about earlier about the leakage issue during startup, by having a proper design and construction happen, then you can avoid any startup issues. As we know, any delays in your startup has huge consequences and even liquidated damages. So any of those can be avoided by using this service. Another is lower material costs due to less field repairs. So any misalignment issues that get avoided, there's some cost savings. And finally, just some quality results for your time-sensitive critical installations. So when your project is a must-fit scenario, this service is an additional layer of technical assurance for your project. So in conclusion, we've defined what a equipment dimensional verification service is. It's our precise dimensional inspection service developed to mitigate construction installation misalignment. We've also talked about how CDI incorporates the latest laser technology like Faro and the Z+F to scan those pieces of equipment, piping, structure, review it, and check it against the baseline design. And also we've talked through why it's important to mitigate those misalignment. We want to reduce this high cost and schedule delays for your project. So with that, I'll conclude my presentation and I'll turn it over to any questions from the audience.
Thank you, Jaime. Great presentation. Just a reminder, you can unmute your line by hitting *6 to ask a question.
Yeah, I've got a question about how much time would be required to apply EDV to, say, a medium-sized pressure vessel, say about 10,000 gallons or so.
Good question. So for that particular application, first we'll deploy the team if it's local at the fabrication shop or your site, or if it's away at another city. But we'll deploy our team. We'll take this time to take the scan,